Good morning, students. So, in the last class, we studied about static equilibrium, dynamic equilibrium. We studied about moment of force, how is it applied, what is clockwise and anti-clockwise moment. We also studied about center of gravity, from where it acts, what is the center of gravity of some standard objects. So, we studied all this in the last class. Now today's class is about uniform circular motion. What is uniform circular motion? How do we define it? Where is it applied? So we are going to learn all about this today. So we move to the next slide. So before beginning with uniform linear motion, I want to revise few points with you all, which we have studied in earlier classes. The first thing is, what is distance and what is displacement? Now, let us take a circle and I put a point A on the circle. Okay. Now, suppose a boy has to run around the circle. So, the boy starts from point A and moves around the circumference of the circle. So, in this case, the distance traveled by boy will be the circumference of the circle, whereas the displacement done by the boy will be 0. Why? Because displacement is the difference in position. The difference from final position to the initial position, that is displacement. Now, boy had started from point A and again reached point A. So, the difference from final position to initial position is 0. He is back to the same point. And so, displacement becomes 0. Now, suppose I am talking about uniform linear motion. We have studied this earlier. Suppose a body is moving in a straight line. If the body is moving equal distance in equal intervals of time, the body is doing linear motion, uniform linear motion. That means the speed of the body is uniform. And we can also say that in this case, velocity is also uniform because the body is moving the same direction. So, velocity is also uniform. The distance is displacement here. Distance and displacement is equal because the body is moving in a straight line further. So, speed is also same. Velocity is also same in the case when a body is moving in a straight line with the same speed or with the same magnitude of velocity. And this is known as uniform linear motion. Now, we have also studied that force is needed to change the velocity or direction of motion of particle to produce acceleration. Acceleration can't be produced on its own. There has to be some force. There has to be some force which changes the velocity or the direction of the moving body. When there is a change in velocity, then only acceleration is produced. You know, the definition of acceleration is rate of change of velocity. So, a force is needed to change the velocity or direction of motion in order to produce acceleration. Without velocity, without the change in velocity, acceleration cannot be produced. So, there are three things which can change the velocity of a body. Number one, change in magnitude of velocity. That means if a body is moving with 30 km per hour and after applying force, it starts moving with 40 km per hour. That means there is a change in velocity, the magnitude of velocity, and therefore acceleration is reduced. Number two, if there is a change in direction, velocity is a vector quantity. It depends upon magnitude as well as direction. So if there is a change in direction, then also the velocity will change. So again, acceleration will be produced at every point where the direction of velocity is changing. Every point acceleration will be produced. And the third case, when both magnitude and direction is changing. You must have understood now. There are three ways in which velocity can change. One is magnitude, one is direction, and the third one is both. Now, in this figure, we can see there is a car. We assume that this is a mass. Okay. Now, force has been applied, and with this applied force, the mass starts to accelerate. So, according to Newton's second law of motion, F is equal to ma. So, m is the mass here, F is the force here, which is producing acceleration in the body. Now, the direction of acceleration is always in the direction of force. The point to be remembered, the direction of acceleration is always in the direction of force. You can see here, force is applied in the direction and the car is accelerating in the same direction. Okay? So now, let's move to the next part of the chapter. My freehand drawing is very bad, students. Please forgive me for that. Now here, I have a triangle. Now suppose I start moving from point A in the direction of B along the line of the triangle. So, I start moving from A and I reach B. The moment I start moving from B to C, velocity changes. That means acceleration is produced. Then from C, I am moving towards A. Again, change in direction. Again, it produces acceleration. So, velocity changes in three places in first figure. We come to a quadrilateral. I begin from A and I am moving towards D. So, I move from A to D. The moment I start from D towards C, change in velocity, acceleration is produced. From C to B, change in velocity, as change in direction, so change in velocity, acceleration is produced, and so on. And in the third figure, that is a hexagon. So, the same way, as many number of turns are there, that many times the velocity is changing and acceleration is produced. So, as many times there is a change in direction, the velocity changes. And as the velocity changes, acceleration is produced. So, we move further. Now here, I have the circle. Now, circle can be assumed as a polygon. What is a polygon? A closed figure having infinite number of sides or many number of sides. So a circle is also a polygon having infinite number of sides. That is not countable. So a circle can be assumed as a polygon having infinite number of sides. And if a body is moving in a circular path, that means the velocity of the body is changing infinite times. And as a result, acceleration is produced at every point on the circumference of the circle. And when the magnitude of the velocity is same and the direction is changing continuously and body is moving in a circular path, this kind of motion is known as uniform circular motion. Have you understood? Let's move further. So, before I begin with the figure in this slide, I want to mention about tangent. What is a tangent? Tangent is a straight line that touches the circle at a point but does not cross it. That means tangent is drawn from a point on the circumference of the circle. Tangent can be drawn from any point on the circumference of the circle, and it is a straight line that touches the circle. So it touches only in a point. So point of contact, there is only one point of contact for a particular tangent. The tangent is a straight line that touches the circle at a point but does not cross it, and it is perpendicular to the radius at that point. So you take any point on the circumference of the circle and draw a radius from there, and just perpendicular to this drawn radius, you draw a straight line that will be the tangent of the circle at that point. Must have understood till now what is a tangent? This was important for this figure, therefore I mentioned. Now in this figure, we can see that the body is moving in a circular path in anti-clockwise motion. Now we can see that velocity, obviously the velocity will change at every point on the circumference of the circle. So the direction of the velocity will be given by the tangent drawn at that point. As the body is moving in anti-clockwise direction. So if I take point A, so direction of velocity at point A, that is, and body is doing an anti-clockwise motion. So velocity of the body will be in the direction which is given by the tangent in anti-clockwise direction. Understood? Now, I have also mentioned that force is required to produce any kind of acceleration in the body. And when velocity is changing, acceleration is produced. That means there is some kind of force. So we are going to speak about it in the next slide. So I mentioned that force is needed to produce any kind of change in velocity or produce acceleration in the body. So here we can see this boy is holding a ball from a thread and is swinging that ball in air. Now there is some force applied by the boy to hold the ball in circular motion. Okay, the moment that boy leaves the thread or the string breaks, you can see the direction that ball goes. The ball is going tangentially. The boy was moving it again in anti-clockwise motion, and you can see the moment the string breaks, the ball is falling in tangentially in anti-clockwise direction. It will go to the ground because the ball is having mass, and due to gravity it will fall down, but for some time it will move tangentially and slowly it will move towards the ground. Okay, so we move further. So as I mentioned earlier also, there is some kind of force needed to change the velocity or direction of motion of the particle to produce acceleration. So here you can see this man again swinging a ball, and you can see that man is applying some force to hold the ball in circular motion. And so acceleration is produced as the force is inward. The man is holding the ball, so man is holding the ball and applying force inside, so the ball continues to be in circular motion. And I said the direction of acceleration will be the same as the direction of force, and as the force is being, the direction of force is towards the center, and so the direction of acceleration will also be towards the center. So here you can see the man is swinging this ball and applying force inward. This inward force is known as centripetal force. Okay? We will understand it better in some slides, but the inward force which is being applied by the man, which keeps the body in continued circular motion, is known as centripetal force. Okay, so here you can see this boy is driving a bicycle in a circular path, and the boy is leaning inward. So again there is a force which is being applied on the boy so that the boy continues to be in the circular path, and this force is known as centripetal force. So if I have to define centripetal force, I'll say centripetal force is a force acting on the body moving in a circular path in a direction towards the center of the circular path. Okay, simple. So now here you can, as the figure is very clear, the boy is leaning inward because of the force which is being applied towards the center of this circular path, and acceleration is also towards the center because direction of acceleration is same as direction of force. Now there are other examples also for centripetal force, like if I talk about an atom. In an atom, the electrons revolve around the nucleus. So there is some force which is binding the electrons to move around the nucleus. Similarly, planets move around the sun. There is some force which is binding the planets to move around the sun in this manner. Similarly, moon also revolves around the earth. So there is some kind of force which is keeping these bodies in circular path, and this force is known as centripetal force. Okay, so we move further in this chapter. Okay, so now we have centrifugal force. What is this? Centrifugal force is a pseudo force, false force. It doesn't be, it is not there, but it is only experienced. It is a pseudo force or a false force. It is only experienced by an observer who is moving with the body. Okay. Now you can see here in the figure, this boy is holding a boy and moving in circular manner. Can you see? And this boy is flying. Now the boy which is flying can experience this centrifugal force. So this is a false force, and this is only experienced by the observer who is moving with the body, or he is only moving. Now, centrifugal force is opposite to the centripetal force. Its magnitude is also same as centripetal force. but it is not the force of reaction. Please remember, it is not the force of reaction, because action and reaction does not act on the same body. So remember, it is not the force of reaction. Okay? So I told you that centrifugal force is a false force which is only experienced by the observer who is moving with the body, or he himself is moving. So we see it in the later video.
Ready? Wait, stay there now.
Why?
This is the distance.
That's quite a bit.
Ready?
So now here you can see 3 people. The first one is holding the center of the circular swing, and he is also holding the other man, and that man is holding another man, and this swing is going in circular manner, and they all three are swinging, and they all three are in the circular motion with some force which is taking them inward, but they are experiencing an outward force also. The person, you can experience this. You must have been on a merry-go-round, and when you are sitting on the merry-go-round and it is moving, you experience an outward force. Do you? So when you sit over there, you are moving in circular manner. Your hand is inside. You are experiencing a force outward. You are moving in the circular path because there is a force which is moving you in circular manner. But there is a force which is pushing you out. So you must have understood what is centripetal force and what is centrifugal force. In the second one, you can see the moment that man leaves the hand, he is flown away out in tangential manner. Okay. So here you can see I have made it. Centripetal force and centrifugal force are opposite to each other, and the magnitude is also same, but it is not a reactionary force. Centripetal force is a real force, whereas centrifugal force is a false force. In a way, we can say there is only one force which is acting on the body, and that is the tension in the string which is acting inward, and that is known as centripetal force. Okay, I think the things must be clear. I tried to make this as easy as it was possible. Still, if you have any problem, you may ask me in the comments below. I will solve your problem. So, till then, enjoy your day. Be happy. Stay blessed. Thank you so much.